Namaskar, students. Today we will start with a new topic, application of derivatives. There are many applications of derivatives, and I know there is no field in the world where derivative has no application. It is used everywhere. It touches every part of life. We will start with some basic application such as geometrical meaning of derivative. To explain the idea, what I have done here is we have constructed x as well as y axis. Now as far as this graph concerned, you know there is function y equal to f of x which can be plotted this way. Consider point A on the graph whose x coordinate is say x, and obviously the y coordinate is going to be f of x. After that x, let us have a very small increment h which is tending to 0. A small increment in x leads to another point B whose y coordinate is going to be f of x plus h. So there are 2 points. One is A, x comma f of x, and the other one is B, which is x plus h comma f of x plus h. These are 2 points on the curve. When you join A with B, what you see is a chord AB. What you see is a chord AB. You can have a construction. You extend this B up to x-axis and draw perpendicular from A to that line which meets here in M. So AM is perpendicular to this. This one is angle theta. As far as this right angle triangle concerned, you know this side which is BM is obviously f of x plus h minus f of x. How? It is the difference between two y coordinates. This is f of x plus h minus f of x. And what is side AM? You know, you have yourself said that B lies h unit ahead of A. So this distance is h. So in the right angle triangle, this is f of x plus h minus f of x, and this one is h. And therefore, tan theta, which is opposite upon adjacent, is Bm upon Am. Alright, now let us put the value, that is f of x plus h minus f of x, and m is h. This is nothing but slope of the chord AB. Chord. Now what happens if this h which tends to 0, that is it becomes small and small and small, B would start tending to come near to A. So what I have written, as h tends to 0, B tends to A. The moment A and B becomes same, chord no more remains chord, but it becomes tangent. And therefore, slope of the tangent, which was tan theta, is given by, in limiting case, it is given by limit h tends to 0, f of x plus h minus f of x upon h. But this is nothing but the basic principle, first principle of finding derivative, and therefore it is written as f dash x, which is also written as dy by dx. In short, derivative gives us slope of the tangent. Students, once we get slope of the tangent, and which is denoted by m1, then we can always find slope of the normal, could be called as m2, which is minus 1 upon m1. Because tangent and normal, they are perpendicular, so product of their slope is always minus 1. m1, m2 minus 1 for two perpendicular lines. Once you have the point with you, p x1 y1 and the slope, we can always use slope point form to form equation of tangent. Have a look. It is y minus y1, which is m1 into x minus x1, slope point form. You can continue the same formula for finding equation of normal, as y minus y1 is minus 1 upon m1, its slope, times x minus x1. So you got equation of tangent as well as normal. Sometimes what happens, at the same point you got intersection of two curves. So to find angle between two curves is the same as finding angle between two tangents. And how to find angle between two tangents? There are formulae mentioned. You see, it might be two tangents are orthogonal, that is perpendicular to each other. So in that case, the product slope must be equal to minus 1. But if it is not 90 degree, it is acute angle to be found using formula tan theta, which is mod of m1 minus m2 upon 1 plus m1 m2. If m1 m2 is minus 1, obviously tangents are orthogonal, and if m1 equal to m2, then tangents are parallel. Students, let's check few more applications of derivatives. Related rates. You know, derivative is a rate of change of something with respect to something. So here, S if it is displacement, V if it is velocity, and A is acceleration, and of course T is time. So when S changes with respect to T, ds by dt, rate of change of displacement is nothing but velocity. Then rate of change of velocity with respect to time is acceleration. So it is actually the double derivative of displacement that gives you acceleration. Various kinematical equations can be derived using this. You have projectile motion problem, you have linear motion problem. We can solve all physics related problem using something called related rates. There is another application called increasing and decreasing function. You know, in certain interval the function may increase continuously, monotonous increase, or it may decrease. So we will focus ourselves only in some part of the interval, that x must belong to this to this. That's what it is written. If you find your derivative to be positive always in some of the intervals, then function is increasing in that interval. So what you need to understand, how to check whether it is increasing, find the derivative and check its sign. In this interval it comes out to be positive, then it is increasing, and if it comes out to be negative, then it is decreasing function. Increasing, decreasing, it's that simple. It may happen that function goes to some maximum height and then comes back. It may happen that the function comes to a lowest point and then comes up, and that is why we got the third application, that is maximum and minima. The maximum and the minimum is shown here. Have a look. This is a function. You have lesser values, here, but this point, it is the maximum value. The tangent drawn to the curve at x equal to a has a slope 0 because it is horizontal. Similar way it is here. This part is the peak point, that is called maximum, and therefore it is written as maximum at x equal to a. Here in the second graph, it is the lowest point. The tangent is still horizontal, but the point is the lowest. So highest or lowest, the tangent is horizontal. So the criteria, how to find that maximum minimum? You see, you have to first find f dash x, equate it to 0. Once you equate it, there is a polynomial. You solve it, you get roots. Let's assume that root is a. Then what to do? Find f double dash x. Put that value of root into this, check the sign. Once you check the sign, and if it comes up to be negative, then it is going to be maximum at x equal to a. Have a look, don't forget what? If it is less than 0, then maximum. If it is greater than 0, if double dash a is found to be greater than 0, then it is minimum at x equal to a. This method is called second derivative test. Now it may happen that if this second derivative gives you answer 0, so in that case the method fails. Test fails and you got to go for first derivative test, which shall be explained in our next video. Thank you.